That was a very sweet introduction. Thank you, and thank you so much for the applause. I wasn't expecting that at all. Are you guys having a good conference so far? Doesn't seem like it. Are you guys really having a good conference so far? Come on, you can do better. Are you guys really having a good conference so far? That's more like it. All right. First of all, thank you so much. I know the conference is coming to its fag end and you guys are still holding on to your seats. I am pleasantly surprised by that too. So thank you for finding the time. We're going to have an interactive session over here. So feel free to raise your hands, ask questions whenever you feel like I'm talking nonsense, all right? And then if you feel like there is something that you would want to add on to as well, feel free to let us know, all right? There's a lot of content I want to cover, so at times I might just hold off on some of these questions till the end, because I also want to show you some demonstrations of the technology in action, so we'll pace it accordingly. All right, so what are we talking about? We're talking about how MLflow and Azure Machine Learning can form the power couple of the ML Lifecycle Management. For those of you who haven't seen me before, I'm Nishant Thacker. I am a technical product manager for the machine learning platform on Azure. So in essence, I take care of all of the machine learning products, including Azure Databricks' machine learning capabilities, Azure Machine Learning, SQL Server's machine learning capabilities, as well as machine learning services inside of Azure HT Insight as well, right? So all of that is under my portfolio. And as such, it kind of becomes a very kind of obvious thing for me to always decipher, like, how do these products work together? How am I going to have customers build solutions on top of these products, and like, how do they not overlap each other, but rather complement each other, right? And we're going to have that discussion today. And by the end of the session, if you feel like, yeah, you know what, Nishant, what you say does make sense, give me a thumbs up. If you feel like, yeah, you know what, you're just giving me marketing bluff, give me a thumbs down. Please rate the sessions, all right? Now, before we get started, I just wanted to start off with a little bit of context. And like, why are we even talking about ML Lifecycle Management? And why are we even talking about like bringing together multiple tools over here? So it's nothing but just the whole kind of blast or the burst of machine learning, which has come about with the perspective of like bringing in machine learning across all the tools and across all the verticals and horizontals as such. So be it healthcare, be it financial services, be it personalization, digital and like retail, or be it the completely new paradigm of IoT, which has kind of given rebirth to manufacturing as a vertical as a whole as well. And of course, like, this is just a sample set. There are many, many more. There's enormous amount of data. There are a lot of use cases. People are wanting to do machine learning. But what does it actually lead to? Like, when you have this kind of a burst over there, what are we seeing so often? First thing we see is there are data science teams that are creating their own processes within their own silos, okay? Second thing we see is it is not just the data science teams that are wanting to leverage machine learning, but a lot of adjoining teams are trying to dip their toes with machine learning as well. So data engineers are trying to dip their toes into machine learning. They're trying to find some simple tools. They want to dive into it. They want to create their own models and play around with their own use cases. Third, of course, well, how can the sales teams be left behind? They have an obvious use case. They want to do sales forecasting. They get some out-of-the-box models. They start leveraging them. They start bringing them to life, and they're bringing all of their new tools and practices over here. Again, apart from the sales teams, even the business strategy teams, the biz dev teams, they're wanting to plot against a lot of demographics, et cetera, and find out details. And again, They're bringing in their own data science models into play. In fact, sometimes they're hiring dedicated data scientists to be sitting in these business teams and creating their own processes and data science models around them. And then, of course, our favorite peers, the developers, they cannot be left behind. So they have their own requirements. They feel like, you know what, data scientists, the models that you give me, I cannot embed. I have to completely recode. So why don't I go ahead and create the models myself? That'll be much more easier. Be in the language. I'll be able to embed it. I'll be able to leverage it within the applications. And it's a win-win. You can sit in your ivory tower and keep telling people you're a data scientist, but we are the real workers over here, right? And then comes the problem child. Well, there's the central IT. These guys want to have common processes across all of these environments. These guys are now completely disorganized over here. So what are the kind of problems that are coming across over here? Well, with data science teams, they have security requirements around sensitive data that they're dealing with. And more often than not, they come up with saying, you know what, give me VNets. Where's my security? How do I go ahead and make sure nobody else gets access to this data? How do I ensure this environment is secure over here? With the data engineering environments, again, like they're going ahead and creating their own clusters. Just a few minutes back, somebody was telling me admin privileges are being given and clusters are being created, and they create clusters without deleting them, and we don't even get any notification around that. Well, that is a real problem. Then, RBAC. Sales teams do not want that data to be visible to anybody except for people who need access to it. Similarly, with business teams, they are audited very often. How about audit trails? And then with developers, they don't understand how to spell drift, let alone tracking drift. So all of these problems are going to come into place. And then the central IT teams are going to come up with their own problems around governance and having a single process throughout the organization as a whole. More often than not, the central IT is not just a problem, but it's a bomb waiting to blast, right? Now, the ideal state that we always try to strive for is that there is collaboration across these various teams. There is enormous reuse of assets, be it data, be it the data science models, so that people are not spending time doing the same thing over and over again. And of course, there are reusable pipelines being created around this as well. Again, from a security perspective, of course, you need role-based access control so that people who need data get the data. There is an optimal encryption applied to it, as well as there are VNets that are applied around that space. And then from the perspective of governance, like how do I manage audit trails? How do I do drift tracking? How do I have any kind of resource tracking around compute resources that have been spun up in these spaces? Now, to address these, there are certain tools that come up. But then, for us to be able to understand that, let us first understand the whole machine learning process. Now, this is a representation of the machine learning process. Everybody has their own representations, and we'll just take this one to be one standard representation for today's talk. So, the first stage is, of course, you're building models, all right? Of course, you get some data, you can wrangle through it in your databases or in specialized environments like Azure Databricks. You get this data, now you want to go ahead and create your models on top of it. To create your models, you need compute resources. So now you want to train it on large compute clusters. You need to manage those. Once you have these models, you need to now keep a track of these models. So how do you do that? Well, you need to register and manage this model. Then, once you have these models, you want to go ahead and build an image or package these models. And then further on, you want to go ahead and deploy these models. Now again, all of this needs to be orchestrated as well so that if there is a need, you can go back to a certain step. If there's a retraining loop to be created, you can go ahead and create that as well over here. Now, it's not a linear process as such. It's actually the DevOps loop for machine learning, where you're getting all of this data, your data scientists are training and testing these models on an ongoing basis, you're registering these models, you're building images, you're deploying them, you're observing them, you're rebuilding them, and then again, training and testing them, and so on and so forth. Now, this is great, but what do I do? How do I go ahead and build this? Like, are there any tools available today that can help me go ahead and put this into action? Why not? There are a lot of tools available. In fact, Matei in his talk today talked about some of the other tools which are proprietary tools that are not available to the general public. Like Uber has Michelangelo and Google has their own tools, and I don't know, maybe some other entity has something else around that space. But these are tools on the slide that are available for everybody to use. Of course, MLflow, talk of the town. Over the last 2 days, I'm sure nobody in this room has not heard of MLflow, unless you've been living under a rock. But again, there are other tools as well, and the first ones that come to mind are the 3 primary clouds that we can talk of, and like their machine learning platforms, because they've seen this problem firsthand with their customers, and they've built tools around that space. So with Azure, it's Azure Machine Learning. I'm guessing with AWS, it's SageMaker that has some kind of tooling around this, and with Google, it's the Cloud ML or the Cloud ML engine, as they've started calling it now, right? Now, for the purposes of this talk, we would concentrate on MLflow and Azure Machine Learning, but you can extrapolate certain concepts to MLflow being an open API and extending to even other platforms or tools that are available that are not represented on this slide, okay? So what are the MLflow components? Of course, with MLflow, you have concepts like tracking, you have concepts like projects, and you have concepts like models, right? What does tracking allow us to do? Yeah, of course, it allows us to go ahead and record and query experiments, maybe some data, potentially even some config, and eventually the results, right? Projects, this one's a little bit hazy, because the definition of projects with MLflow is very different from a definition of a data science project. So like, we'll take it and we'll probably drill a little deeper into it at a later point in time as well. But then what Databricks defines, or MLflow defines projects to be is something like a packaging format for the reproducible runs. So for example, a data scientist in, let's say, team A has been creating an experiment for a data scientist in team B, or a data scientist B in team A to be able to reproduce that entire run. They need certain entities, and that is actually a project. Well, ideally, that's an experiment. Okay, and we'll tear down the different pieces of projects at a later point in time. Again, the third aspect, models, and in today's keynote, we all saw how that got enhanced. So the first thing is, of course, having a model format, but then also implementing model tracking via model registry and all of those aspects, and like model versioning capabilities, etc. So all of those are important aspects. Now, what is all of this? Of course, experiment tracking. Well, if you look at it from the perspective of a managed MLflow implementation in services like Azure Databricks, it's a very easy to use environment. Like, you're just going in there, you're applying certain aspects of logging the metrics, and you have your experiment tracked. So you have your workspaces and notebooks pre-provisioned with MLflow configured. You have experiment managing via the ACLs control, so you know not everybody is getting access to the experiments that you've created if you don't want them to have access to it. The other piece is the reproducible projects, and we talked about this a little bit earlier, but like this one's, again, now the definition changes a little bit. So it becomes how they are maintaining the code files and how they're maintaining Git hashes, etc., for the experiments in GitHub. I don't know how this is like unique, but it is important for sure. Whenever you're creating new models, you're writing some scripts. Where are those scripts being stored? Where is the versioning of those scripts happening? What happens when certain aspects of those scripts change? Or what happens when certain configurations change, etc. Okay? And then the third piece is, of course, the model deployment aspects, where it's kind of tracking the model as a whole, right? Now, there's more to like the ML lifecycle management than just those models. But if you look at it from implementing an MLflow-based model management lifecycle, this is what it looks like. You prep data, you potentially use Delta Lake, you build models, you use MLflow project tracking, and then when you deploy models, you're looking at MLflow models. Now, remember, deployment with Databricks only applies to deployment into Databricks only as well. So ideas like for batch inferencing, you probably are doing it via Data Frame API or via Delta API. For streaming, you're doing it via Spark streaming or, again, via Delta APIs. Now, why is that a point of concern? That is a point of concern because no data scientist wants a dependency on a Spark cluster to be able to score their models. When a data science team creates models, they want it to be deployed in a place where it can be called by developers or offered as a web service very easily, right? Now, how does that happen? Within Spark, that's very difficult. Like, why do I keep a cluster open and running to make that happen? That really doesn't sound right. To train my models, if I need a cluster, that's fine. I can have that. But why do I need it for scoring unless I have like a need for Spark or the engine behind it or the Databricks runtime behind it to be able to score against it, okay? But again, there's more to the ML lifecycle, as I said. Let's take a look at how we understand the ML lifecycle, and internally within Microsoft and even in the industry at large, we refer to this entire process as MLOps. Just a quick note, I see a lot of people taking pictures of these slides. I mean, the slides are already published. The slides are available at aka.ms/AML-MLflow. It was on the first slide over there. The entire slide deck, I've published it, and it's available to you, right? But just take a look at this. Like, from an MLOps perspective, a data scientist comes in, they're collaborating, right? So they're bringing in a bunch of people together, they're writing scripts, these scripts are generating models. So these scripts need to be version controlled. The configs need to be version controlled. All of this can happen inside of GitHub. Perfect. Amazing environment. That's what it's meant for. That's what it's been doing for years. It's probably the most robust environment to do. Let's leverage that. What after that? Then they go ahead and train models. Then they go ahead and validate the models. Then they go ahead and potentially deploy those models. And then they start monitoring these models as well. Now, they completely lost track, right? What happens when they have to redo it? What happens when they have to go back and see certain metrics of it? As a data scientist, if I'm just following one model at a time, I've completely lost track of the model once it's created and deployed and done. That's one cycle. The next time I want to do it, I start the cycle all over again. Where is the reuse? Where is the security? Where is the tracking? All of that aspect is completely lost. Let's take a look at it from the perspective of somebody who does it from Azure Machine Learning, right? When you're looking at it from Azure Machine Learning's perspective, the first thing you want is version control of code, data sets, and environment versioning. So all of that happens in GitHub. When you train a model, now you start tracking experiments, tracking models, and tracking hyperparameters. These are important for you to reproduce these runs if you need to at a certain point in time. Now, when you validate these models, again, you want to start tracking model efficacy. You want to compare against other models that were created. Remember, previous loop, you couldn't do that because you were not tracking anything. There was no metrics for you to compare against. Now you have to do that. You can track dependencies around that as well. As you go into deployment, now you go ahead and see that you have a bunch of capabilities over here that track images and containers and potentially even go ahead and track the actual deployments where they are happening. But furthermore, you're now doing actual model management. You're doing drift analysis on top of this. But that's not the end of it. When you have these metrics, you now want to go ahead and create a retraining loop around these models as well, which kind of helps you maintain an audit trail. It also helps you implement model interpretability, and it helps you bring model performance analysis into the mix over here. Now that's the power of managing this whole life cycle. And if you look at the tools that we talked about, very few of them can cater through the entire life cycle as a whole. When you look at MLOps as a whole, it is just this particular trained model tracking that gets catered to potentially by MLflow. Some of the other tools don't even cater to that totally over here. How about the rest of the capabilities that come in with validate, deployment, monitoring, and the tracking parameters that we need to confine to as a result of that? That is where Azure Machine Learning really comes to the fore. It takes you from just being able to track that first step in the ML lifecycle to being able to manage the end-to-end lifecycle as a whole from the perspective of doing machine learning on Azure. Now, you may ask, what is Azure Machine Learning? Well, Azure Machine Learning is a service on Azure which allows you to create models, manage models, deploy models. It has strong bindings with other Azure services so that when you require compute resources, you have them handy. When you require inferencing resources, you have them handy as well. And then, of course, it comes with a bunch of capabilities like automated machine learning and MLOps, and it supports all the open source frameworks, and of course, it is offered as a tool-agnostic Python SDK as well. So you want to do it in the cloud, you want to do it on-prem, you want to do it on some other cloud, go ahead. What's more, Azure Machine Learning is actually free. We don't charge you anything for all of these capabilities combined. We only charge you for the compute that you spin up when you train your models. So just like imagine offering that entire plumbing of the ML lifecycle for free that you can leverage via a Python SDK. Okay? Now, if there were three things that we could talk about from an Azure Machine Learning perspective, it is how simplified it makes machine learning, how it helps the end-to-end lifecycle management, and how it does it staying open across all libraries and frameworks that are present over there. Now, I want to actually draw us back to this particular slide over here and jump into a quick demonstration to show you how all of this can be made possible by combining the power of MLflow and Azure Machine Learning together. Now, ideally speaking, the entire lifecycle I could have implemented in Azure Machine Learning because Azure Machine Learning also has the capabilities that MLflow has. But since we're talking about how MLflow and Azure Machine Learning work together, for whatever reasons, if you're choosing to implement that first step on MLflow, it definitely is an amazing tool and it's getting more capabilities on a day-by-day basis. Let's see how both of these tools work together so that it does not become like a disconnected architecture, and it's an architecture that has a very seamless handoff from one stage to the other over here. So let's dive into the demo over here. My screen's visible. Lovely. All right. So in this particular example, let's just go ahead and say I'm going to have an environment set up. So what are we going to do over here? The first thing is you're just going to go ahead and install Azure ML MLflow. Now, this is nothing. This is just a flavor of the MLflow which integrates with Azure ML. So this is, again, like part of the MLflow family itself, okay? The second thing we need is an Azure ML workspace or an environment so that you know, like, where are you tracking it and what are you maintaining over there. And then all that we need to do is set the MLflow API or the MLflow Tracking URI to an Azure ML workspace environment. How do I do that? Well, first thing over here is just importing both MLflow and Azure ML. Both of these are SDKs, so you can very well install them on top of, and I'm in an Azure Databricks notebook over here. Now, this is important. Keep in mind, data scientists don't always stay in the same environment. So I'll show you how this also applies to other environments and how we can leverage it from there again, all right? So I'm just going to go ahead and give it my Azure Machine Learning workspace. This is my subscription, my resource group, my workspace name over here. And then all that I'm doing is just getting it, like I'm trying to test this out for myself. The next thing I want to do is I want to get the MLflow Tracking URI and set the tracking URI for MLflow to the Azure Machine Learning MLflow Tracking URI. Important step, important to understand well. MLflow has its own tracking server that runs behind the scenes, right? That tracking server has a tracking URI, which is set by default. So the next time you run, let's say, a MLflow model run, everything gets tracked into the MLflow tracking server. What I'm resetting it over here is my MLflow's tracking server should now start pointing to Azure Machine Learning. And that has happened because we have integrated Azure Machine Learning and MLflow together. The APIs for Azure Machine Learning and MLflow talk to each other, and they can hand over information from a run on one tracking server to a run or to be kind of displayed on another tracking server, that is the Azure ML tracking server over there, okay? Now, I'm just going to go ahead and create a sample application over here. This is not interesting. This is an MNest one. I'm just trying to digit recognizer. Everybody's seen this 1,000 times before. All that I'm providing over here is some experiment name, and I'm setting MLflow. Remember, I'm not doing anything with respect to Azure ML over here. I'm setting the MLflow experiment name to be the experiment name that I define. And then I start kind of creating my model script over here. But as I create the model script, either I do an autolog, as we saw in the morning that MLflow has now enabled, that it can automatically start logging everything over here. Or in this case, I'm actually doing a couple of metrics being logged over here. So I'm logging the particular metric over here, and I'm logging another metric over here, all right? Now, all of this following MLflow's API. Nothing's very different over here again. Now, I just run this and save this as my PyTorch model, and as you can see very clearly, it took a few seconds, and then I start off with the MLflow experiment, and I start logging it. And this one takes a few minutes. That's the only reason why I'm not running these cells over here, because you'd have to stare at my face for 2 minutes or whatever that time is. But the important thing is, look at this link over here. It's provided me, now an MLflow run has provided me an Azure portal link to go see the run details. Why is that? Anybody? Perfect. Since I pointed my MLflow tracking server to the Azure Machine Learning tracking server, it does not need to track anything anymore for me. And if I go to the runs, it's not going to show me anything inside of my MLflow tracking server anymore as well. Whereas it's going to show me everything inside the Azure Machine Learning tracking server. So if I come to experiments, should be able to see my PyTorch with MLflow experiment over here, and I can see all the details about this run that I want to go ahead and track and manage and do whatever I need to. In fact, should even be able to track the respective models over here. So I see the PyTorch MNIST model over here. I can see whatever is happening with this model. Now, I'm going to go back over here. This is just the first step, though. Like, I have my MLflow tracking server set to Azure ML. I could see all the metrics over there. But what next? Like, MLflow just stops there, right? I mean, I have the model. I could potentially go ahead and package it up and score it against a batch query inside of my Spark cluster. But is that really how we score against models? We don't, right? So now, what I'm going to do is, I'm going to natively use Azure ML. Notice, I did not change the tool. I did not change the API. I did not do anything over here. I have now started using Azure ML's build image function to go ahead and create a container or an image for the model that I just created over here. Now, once I have that, again, from Azure ML directly without changing any APIs, now I am deploying this to an Azure container instance. Now, I could have deployed it to a Kubernetes cluster if I wanted to, if I knew there were hundreds of thousands of people who were trying to connect to this over here. But in this case, it's just for testing purposes, so I'm deploying it to a single container instance. That's the ACI web service, Azure Container Instance Web Service, right? It's as simple as that. Now I have the image, I can deploy the image over here, and I can start testing the image against the web service URL. See this? It's also provided me with a scoring URI. And this can happen wherever your customers are. Notice the North Europe over there. I was able to deploy it because I was in Amsterdam. I was able to deploy it closest to where I am so that the scoring is not delayed over there as well, right? Now, this is great. I have this. I got the requests. I now have a test environment as well. What about data scientists who do not want to use Databricks or who do not want to use Spark or who do not want to use this particular notebook and they want to start creating their own environments and potentially use Jupyter? Well, sure. Come on in, Jupyter. You can come in over here. You can start creating your models. The only thing that we've requested you to do over here is, again, just go in, plot your workspace. So again, the Azure ML workspace comes in over here. And in this case, we're not even using the Databricks cluster as the compute environment. In this case, we're using the native Azure Machine Learning compute to run the machine learning models on top of this. And this time, instead of PyTorch, I'm going to go ahead and create a scikit-learn MNIST model, right? Great. I can go ahead and do that. Perfect. I can now download it. I can play with some sample images. I can create a file data set. I can register this data set as well. Another important aspect. If you're trying to recreate this experiment for another person in another environment, they would need the exact same data set that you have feature engineered and wrangled through and then saved it back. So a dataset versioning is also available inside of Azure Machine Learning if you so wanted to do this. And then you just train it on a remote cluster. Now again, all of this is just you creating the model and deploying the model, but the interesting part is when you're trying to register this model. This time, instead of using MLflow, I decide to go ahead and register it using the Azure Machine Learning's register model capability. Again, MLflow, Azure ML, both of them now start showing up inside the same workspace inside the Experiments tab. Go ahead. Absolutely.
Okay. How about the security, that scenario? What's the kind of
you can define. Perfect. Now, the question for everybody in the room, I versioned the data set. It's maintained with some metadata in the workspace. How about access to that data set? The data set is defined, which can be ACLed or access controlled with definitions into its metadata itself. So when you're registering it, you can define certain access control policies around that data set to prevent it from being even seen by others who have access to it. And we'll see a little more into that at a certain stage. But I just wanted to show you, here's the sklearn MNIST model. Here's the PyTorch MLflow model. Both of them existing inside the same experiments workspace over here. And even this one should have a model that's available for me, all right? Now again, all metrics being tracked for this as well. You can come in over here, you can select what's happening, you can potentially even see that I ran this particular model twice, so it has a couple of versions of it, and it has some descriptions around that as well. And I can now come in to the sklearn model and see if there are any deployments of this particular model at all. Well, I have not had the chance to deploy this one yet, but potentially I have had a chance to deploy some other model before, as we can clearly see from the environments over here. You see, the MLflow model we deployed using that ACI service. You can clearly see the MLflow model being shown here. It's a predict using web service, and the compute type that it's deployed on is the ACI service. In fact, I can even go ahead and track the image for that particular model over here, the PyTorch MNIST model over here. And then I can even track all deployments that have happened across my workspace in a single environment. So irrespective, and in fact, not just the notebook environment, I talked about some easy to use environments like Visual Studio, the visual interface. You can even go ahead and create your models using drag and drop capabilities inside of Azure Machine Learning, and all of the same capabilities and all of the same tracking is going to apply to this model as well back inside the Azure Machine Learning workspace. So be it Databricks and you're using MLflow with it, or be it environments using like notebooks like Jupyter, or be it the visual interface and capabilities around that. All of this is maintained inside this environment. Now, there was a question around governance, so I'm just going to go ahead and quickly dive into that over here before I forget. So one is, of course, the access control that we have for the workspace itself. So I can come in over here and say, okay, you know what, I'm going to go ahead and do a role assignment. I'm going to add people to have particular level of access to certain set of assets over here. But more importantly, I can even go ahead and define new roles over here that can be leveraged. So for example, a master reader. What is that? Like, this is just a custom role that has been defined over here. Or you could go ahead and define, like, say, a senior data scientist role over here and give them specific rights, or give that role specific rights to entities within the workspace as well. What's even more interesting is the usage and quotas, where you can now come in over here and you can start assigning policies to specific compute types over here, so that your data scientists or your data engineering teams don't start designing their own models. Now you see, my workspace over here has a certain set of quotas, and I can go ahead and configure them. So I can say, you know what, for DV2 family CPUs, for this particular workspace, instead of 100, limit it to 20 and save. Now, irrespective of how many data scientists log into my workspace, they can never exceed the quota that I have defined over there. So now for those problems where clusters were created without permission and they were hanging around, those can no longer happen. More importantly, all clusters created are actually auto-scaling, so they spin down once they are not being utilized as such. All right? Just getting back to the slides here and getting through it a little more quickly. Here's the summary that we just saw as part of the demonstration for MLflow and Azure Machine Learning working together. So be it your local machine with your Python SDK, be it a virtual machine in the cloud, whether it's the data science virtual machine, be it the Azure Machine Learning compute, or be it from within Azure Databricks, MLflow APIs can be leveraged to experiment and log all of these metrics onto Azure Machine Learning. The only thing that you need to do, set the tracking URL to an Azure Machine Learning workspace. And it's as simple as that, right? Since MLflow works on almost all other environments as well that we showed, except for the visual interface, it should work as seamlessly. In fact, I could use MLflow and Azure ML interchangeably over there from an API perspective. As long as the tracking URL server is pointed to the Azure Machine Learning workspace, I can track everything in a single pane of glass over there. Now, the second thing I wanted to really talk about is like, what is it and how does it actually work together? So MLflow tracks certain things. Azure Machine Learning, of course, is a little more expansive, so it tracks a few more things. So how do they track it? Well, essentially the way they track it is like MLflow tracks everything inside of its database. Azure Machine Learning potentially tracks everything inside of its database. And then we could get these two databases to talk to each other, right? That's one way of doing it. Perfect. I mean, you can store it, you can display it in your own tracking server. Azure Machine Learning can show all of theirs inside their tracking server. As long as both of the tracking servers have a database and both of them can talk to each other, the information can be shared across both of these tracking workspaces or tracking environments. But why not get MLflow to, in addition to writing to its own environment, also write to the Azure Machine Learning environment over there? Well, that's the fun part, because now things start becoming very interesting. Irrespective of the environment that you're in, now you're being able to see everything in a single pane of glass. And eventually, when you already have everything inside of the Azure Machine Learning workspace to see, do you really need this particular environment at all over here, or this particular database at all over here? You can just leverage the MLflow APIs, which are so powerful and so user-friendly for you to be able to log all of those metrics. Use those APIs to be able to log it directly into the Azure Machine Learning environment as well. And that's also an option, all right? Now, that said, again, like from a model deployment perspective as well, think you could bring in any kind of model and you can just go ahead and leverage MLflow to be able to track, but then Azure ML to be able to package and deploy to scalable web service URLs instead of keeping it inside of a Spark cluster or a Spark job as a whole. How does MLflow work? We've clearly seen tracking. Again, now it can all work via Azure Machine Learning. Same thing with the models. It can work via Azure Machine Learning. For the projects, those are comprising of the other smaller components that you saw inside of Azure Machine Learning already. So Azure Machine Learning keeps a better track of those components than tracking them via the MLflow APIs itself. Just even wanted to kind of share something over here in terms of like, how did we start working on it and where is it leading to? So started off with the preview in May, kind of gone GA in August, and again, in December, we are introducing even more capabilities over there. And recap of the steps, just an install of Azure ML MLflow, setting the Azure ML workspace, and the tracking URI to Azure ML. With that, I'll open it up for questions, and thank you for your time. I hope you enjoyed the session. Thank you.